We are jumping into 10.5. I'm skipping 10.4. We'll come back to it. I just wanted to finish everything that we would be doing with area first. So the lesson today is called area and trig. So let's go ahead and do the start thinking part. It says, explain the process of calculating the area of the following figure. First things first, this thing is a regular hexagon. What is the formula for the area of a regular hexagon? 1/2 A P. Fantastic. Now, when we look at this one, we have a 30, 60, 90 embedded into, we've got that 30, 60, 90 embedded into our figure. So we know that the whole side length is 10. So this is going to be 5. And what is that going to be on our 30, 60, 90 triangle? 5 rad 3. Fantastic. So I can now say 1/2 apothem, which is 5 rad 3, times perimeter. If it's 10 for the side length and there are 6 sides, then it is going to be times 60. And when you multiply all that stuff together, you end up with, let's see, half of 60 is 30. 30 times 5 is 150. 150 rad 3 inches squared. Anybody have any questions on that? No. Okay, let's take a look at this new problem right here. Don't write this down yet. We're just going to look at it. So once again, this is a regular polygon. So I would go over and need to find out the apothem because I'm going to do 1/2 apothem times perimeter. Don't write this down yet. So tell me what I'm doing wrong here. This is going to be 5. So this is going to be 5 rad 3. Why is that wrong? It is not a 30, 60, 90 triangle. So let me go ahead and delete this stuff out and let's cover that for 1 second. So the only time you are going to have a 30, 60, 90 triangle is going to be with a hexagon and with a equilateral triangle. Those are the 2 times. When you have a figure like this, you're still going to use 1/2 apothem times perimeter, but it's no longer going to be a 30, 60, 90. So let's figure out what it is going to be. Once again, your calculator is going to be used a lot in this lesson. How many degrees is that? The whole entire angle right here is going to be 360 divided by the number of triangles, which is 5. What does that give us? 360 divided by 5 is 72. Then when I drop down my apothem right here, then the triangle is not going to be 72 for this angle. It is going to be 36. So you go, oh, well, what am I going to do now? Because we basically have this triangle where this is 36 degrees. Over here is going to be half the side length, which is 5. And we're going to need to know what the apothem is. What the heck is that apothem going to be? So we cannot use 30, 60, 90s. It's 36. So it's going to be close to what a 30, 60, 90 would get you, but not exactly. So does anybody have any ideas on how we would go about solving for our apothem so we can actually plug it into the formula? Trig, fantastic. So we need to make sure that our calculator is in degree mode, and I would first set this up to find out what x is. So we know that this is opposite and adjacent, which is tangent. So tangent of 36 degrees equals opposite over adjacent. And you need to remember how to solve a equation that has trig in it. Remember, we always multiply by the denominator. So now we have x times tan of 36 equals 5. And then I can divide both sides by tan of 36. So you get x equals 5 divided by tan of 36. The main reason why this lesson is challenging is because you are not allowed to round until the very, 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 very end. So you can't go over and say 5 tangent to 36 in your calculator and just round that as a decimal and put it in for your apothem. You can't do that because then you're going to be rounding off of rounding, which messes up in the end. So what we're going to do is just write out the equation with everything we have. 1/2, the apothem. The apothem is 5 divided by tan of 36, and then times the perimeter. Well, 10 is a side length, and there are 5 sides, so that would be 50. The way I recommend you guys doing this is you will go over and put this in your calculator. 5 divided by tan of 36, enter and leave it in your calculator. Do not round. Then just say times 50 and leave it in your calculator, and then divide by 2, and then finally round. So everybody is going to grab their calculator. You're going to say 5 divided by tangent of 36, enter. Make sure you get 6.88. If you get anything else, tell me, and that means your calculator is in a radian mode. But remember, we're not rounding that. 5 divided by tan of 36 is 6.8819, blah, 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 blah. We're going to leave it in our calculator. Now just say times 50. You now have 344.09548. And leave it in your calculator, and then just say times 0.5, and that gives you 172.0 approximately inches squared. Does anybody have any questions on that? Yes. Question or just stretching? Okay, I want to show you one other thing that you guys can do if you have a graphing calculator. So take a look on your calculator, and on the left-hand side, you have second, you have alpha, you have math, you have all this stuff. Almost at the bottom, right, one above on, it says STO. What that is if you ever want to store a value into your calculator that you're going to use later on, and you want to store it as X, what you can do, everybody right now, really quickly, put in 5 divided by tangent of 36. 5 divided by tangent of 36. If you wanted to keep that number exactly as it is, but you don't want to have to write it all out into your calculator, go ahead and press the STO button. It says answer, and then it says arrow, which means it's storing. And then if you're at the second button to the right one and down one is where it has an X and a T and all this other, press that. So now it is saying, and then press enter. What that does, it'll say 6.8819 again. What that means is until you change it into your calculator, anytime you push X, it thinks you want 6.881909.602. So right now, I could have gone over and stored this as X, and then in my calculator, I could have said 0.5 times X times 50. And your calculator thinks that X means that exact number. It means exactly this. So if you ever want to store something into your calculator, for example, when I was grading your quizzes, it is out of 30 points. I said 30, store as X. And that way I could say X minus 5 minus 2 divided by X, and it gives me your percentage. Instead of having to press 2 buttons, 3, 0, I just stored it as X. And until I changed it in my calculator, it thought that X meant 30. And now your calculator thinks X means this until you change it. Does anybody have any questions on that? Okay, I'm going to show you the hardest of the bunch. Let's go to the hardest of the bunch where there's so much stuff going on. Let's look at this problem right here. We're going to do these 2 problems, and then you guys will do the other 2, and then you'll have pretty much everything you need. So on this problem right here, we know the formula is going to be 1/2 apothem times perimeter. Is a 30, 60, 90 embedded inside of a 5-sided figure? No. So what you need to do is we are going to draw out the triangle. We already learned that this is going to be 36 degrees. We just did that problem above. It would be something different if it wasn't a 5-sided figure, but for a 5-sided figure, it's 36. I am going to call X the bottom. I am going to call Y the apothem. And then we learned that this is 8 right here. So what I'm going to do is I'm going to figure out what X is and Y is as a trig ratio. So let's do the X one first. Ignore Y. X is opposite and hypotenuse. Which one uses opposite and hypotenuse? Sine. So let's go ahead and do that. Sine of 36 degrees equals opposite over hypotenuse. Which means our X value, half of the side, is 8 sines of 36. 8 sine 36. We know what half of the side length is, and we'll deal with that in just a second. But I want to find out what Y is now. Now y, if we ignore the x, y in the 8 is adjacent and hypotenuse. What trig ratio uses adjacent and hypotenuse? Cosine. So I can write cosine of 36 equals adjacent over hypotenuse. And when I multiply both sides by 8, I get y equals 8 cosine of 36. That is just a number. I just don't want to figure out what it is as a number, because then you're going to be tempted to round it. And if you round it, then it's going to mess up your answer later on. It's like when you were little kids and you played that game of telephone. Everybody play telephone before? Long chain. You say something to the person next to you, they say something, and every time there's this small little change. And by the end, you find out that the small change became bigger and bigger and bigger. So, on this one, now we have to put everything into our formula. So we have 1/2 is just 1/2. Which one was it, the y or the x that's my apothem? The y. So I'm now going to put 8 cosine of 36. That is just a number. I just don't want to make it into a number yet because I want it to be exact. Now here is where it gets kind of tricky. X is only half of the side. So when we find out that x is 8 sines of 36, how many sines of 36 is the whole side? 16 of the sine 36. And now since there are 5 sides, what is that whole entire perimeter? Is 16 times 5 80? Thank you. Okay, so we have 80 sine of 36. This is representing our apothem, which we found out was y. This took a little bit of work because we only found out half the side, which we had to double and we had to multiply by 5. It is. Now you have a few choices. You can either try to put this whole thing in your calculator with parentheses and see if you get the right answer, or you can simplify it a little bit, which is what I do. Or you could store this one as x in your calculator and then say 1/2 8 cosine of 36 times x. Not this x, the x that we stored in our calculator. But let me show you how I do it. I'm going to simplify the number aspect. What is half of 8? 4. And what is 4 times 80? 4 times 80 is 320. So now simplifying all the number aspects gives me 320 cosine of 36, sine of 36. Now that is simplified, and we can just put that simplified thing in our calculator, and we don't have to worry too much about the parentheses as much. So go ahead and put that into your calculator. 320 times cosine of 36, parentheses, sine of 36. And you should get 152.2. 152.2 inches squared. That is as hard as it gets. Hey, question for you. Is this angle always going to be 36 when you do the problem? Is it always going to be 36? No. It is sometimes going to be something different. Does anybody have any questions about how I did number 1? It's the hardest part, I would say, is the whole, this is 8 sines. So the whole thing is 16 sines, and the perimeter is how many sines of 36? No questions? Okay, let's go to another problem. This one right here. How many sides does that have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 sides. We can write out part of our formula, 1/2 apothem, which is 12, and we just need to know what the perimeter is. So let's draw our triangle here. This is 12. We're solving for that. Do I go over and put a 36 in there because this is 36 in this problem? No. So you have to do 360 divided by the number of sides, which is 10. That will give you the whole entire angle, which is 36. And when you cut it in half, how many degrees is right here? 18. 18 degrees. All right, what trig ratio are we going to use to find out x? Opposite and adjacent is tangent. So we have tangent of 18 degrees equals opposite over adjacent. I multiply both sides by 12 to get rid of that 12. So we find out that x, half of the side, is 12 tangent of 18. We now know that half of the side, because that's where the triangle is 12 of the tangents. So what is the whole entire side? How many tangents of, what is it? 24 tangents of 18. And now what is the whole perimeter since there are 10 sides? 240 tangents of 18. Now, just like before, let's go ahead and just simplify that a little bit. Half of 12 is 6. And then in my calculator, I'm going to say 6 times 24. 144. 144 tangent of 18. Put that in our calculator. 144 tangent of 18. And that gives you 46.8. I don't know if that's what I got last time. So look over it. Do you find any mistakes? You get an extra credit point if you find a mistake. This is 12. That is where the x is. That is tangent. Tangent of 18 equals x over 12. Multiply by 12. 12 tangent of 18. Double it, 24. And there's 10 sides. That's 240. Everything feels right to me. Does anybody have any questions? I'm going to have you guys practice some in a second, but I'm going to change a problem really quickly. And let me explain why I'm going to change this problem. This has 7 sides. Watch this. If you do 360 divided by 7 and you put it in your calculator, it gives you something really ugly. It gives you 51.42857,143. That's not good. We don't want to go over and round. And then when I do half of it, because I want half the angle, it's going to be 360 divided by 14. And that's another decimal that does not round. So if we were to stick with this being 7 sides, you guys would have to leave your degrees as a fraction. You would not round it. You would just, every time, instead of saying like tangent of 18, you would say tangent of 360 divided by 14. Because that would give you the exact number. You do not ever want to round unless you have to. But what I'm going to do, since you guys are just practicing right now and you're easing into it, let's pretend like this thing is an octagon, okay? So don't do this as if this problem was 7 sides. Do it as if it was 8 sides. And just for counting's sake, that's 12 sides. People at home, you are going to pause the video and you're going to try these 2 problems. Yes, the numbering is off. Pretend like this one is an octagon and do the problem, and this one is a dodecagon. Pause the video, try the problem, and check your answer when you are done. People in class, go ahead and do it. I'll do it on the board. Alrighty, so let's take a look at this problem right here. I knew that it was where we changed it to be an octagon, so I did 360 degrees divided by 8 gave me 45, and when I divided by 2 to get the angle inside my right triangle, it was 22.5. All I needed was the apothem, so I put the x where the apothem was. When I solved for the apothem, I found out that x was equal to 10 over tangent of 22.5. I put it into my formula, 1/2 apothem times perimeter, and it spit out 1931.4. Does anybody have any questions on that? No? Okay, on my next problem, it was a 12-sider, so I found out the whole angle was 30 degrees. And when I divided by 2 to find out the missing piece, it was a 15. So this is the missing angle right there inside my right triangle. It's 15 degrees. I had to solve for both y and x. Y is my apothem. X is half of the side length. When I got x being half of the side length, which was 10 sine of 15, I had to double it to get the total side length was 20 sine of 15. And then I multiplied by the 12 sides to get 240 sine of 15. I then popped it in my calculator and got 300 degrees. Does anybody have any questions on that? So why did I say degrees? 300. You could have got an extra credit point for pointing that out. 300 inches squared. I know I was in degree mode. I don't know what I'm talking about. Okay, let's move on. Now, What is one of the formulas we know for the area of a triangle? It is what? 1/2 base times height. If that triangle is equilateral, we could also use 1/2 apothem times perimeter, but only if it's equilateral. I want to come up with another formula for you. So what we are going to use, we're not doing that because we don't want to just only look at equilateral triangles. We're going to adapt this for a problem that looks like that. So this, you have a base, you don't have a height, you would have to do some trig. I want just a formula I can use whenever I have a situation like this. So let's take a look at this. We know we have the formula 1/2 base times height. Okay, now on here, base is going to be b. So I'm going to say 1/2 b, and then I have to find out what the height is. Here is the height. The way that I would solve for this is I would be using trig, okay? So let me go ahead and set up just a problem. Let's say this was 20 degrees. I knew that this was 10 and that this was 30. If I wanted to find out the height, which one of these numbers actually helps for my right triangle that I'm drawing so that I can find out my height? Does the 10 help me or does the 30 help me? Which one is the full side of this right triangle? The 10. So that would be the 10. You would have 20 degrees here. And which trig ratio would you use coming from this angle right here? We have this side, which is opposite, and hypotenuse. Which trig ratio uses opposite and hypotenuse? It's going to be sine. Fantastic. So we call this angle A. To find out what H is, let's set this up. This would be sine of angle A equals the opposite, which is our height, over this, which is C. This is just a little bit confusing because we don't have numbers in here. I want to get the H by itself. How do I get rid of that C? Multiply by C. Great. Multiply by C and multiply by C. So now I know my height is actually C sine of A. So where there used to be a height, I'm going to put C sine of A. That is a new formula for area. That seems confusing. All it says is the area of any triangle is equal to 1/2 of the, let's see, I don't even really like the words here. I'm just going to write it out in different words. The formula is going to be area equals 1/2 side times side times sine of the angle between the sides. 1/2 side times sine of the angle between the sides. So let's take a look at this problem right here. I'm going to throw in an extra number. Let's say that this was 26. Which two sides are important? Which two sides are including an angle? Is it the 10 and the 30 have an angle between it, or the 26 and the 30 that have an angle between it? Which two sides have an angle between it? The 10 and the 30. So watch how easy this is. 1/2 side 10 times side 30 times sine of the angle between the sides. That's it. This formula will always work if you have two sides and an angle between. And now you just pop that in your calculator. You can use 0.5 instead of 1/2. 0.5 times 10 times 30 times sine of 40. And that gives you 96.4 approximately inches squared. Does anybody have any questions? We're not done yet. Look at this one. Is this eligible for the formula we just learned? Do you have two sides and an angle between it? It does. So we would have 1/2 side times side. Is that an 8 or a 6? An 8. 1/2 side times sine of the angle between the two sides, which is 30. 1/2 side. You can use this with an equilateral triangle, because if this is 10 and this is 10, what is the angle inside of an equilateral triangle? Nope. 60 degrees. You could do 1/2 10 times 10 times sine of the angle. So this is super helpful. Let's just put that into our calculator really quickly. 0.5 times 24 times 8 times sine of 30. And that spits out 48. Did everybody else get 48 when they put it in their calculator? Great. As you know in my notes, I always put extra stuff if we have time for it. We don't have time for it, but you have everything you need from today's lesson. Thanks for watching at home.